Bismillahirrahmanirrahim. Welcome back to another interesting video. So in this video I'm going to discuss symmetric functions of roots of a quadratic equations and in terms of its coefficient. Here we have if alpha and beta are the roots of a quadratic equation, which is x squared plus bx plus c is equal to 0, then find the values of symmetric functions of the given quadratic equations in terms of its coefficients. Now here we are given some roots, which is alpha plus beta, alpha into beta, alpha square and plus beta square, alpha cube plus beta cube, 1 over alpha, 1 plus 1 over beta, 1 over alpha square plus 1 over beta square. Now let's first find out the values of alpha plus beta. Is alpha and beta are the roots of the quadratic equations. We already discussed this in previous lecture and previous videos. The values of alpha plus beta, sum of roots of a quadratic equation. So as alpha and beta are roots of a quadratic equation is ax squared plus bx plus c. So sum of roots, we know that sum of roots, which is alpha plus beta, is equal to minus b divided by a. This is the values sum of roots of a given quadratic equation. Now second one, we have alpha into beta, the products of roots. So we know that the products of roots of a quadratic equation is equal to c divided by a. We know that alpha into beta, the products of roots is equal to c divided by a. Now here we have to discuss alpha square plus beta square. Since alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha and beta, because if we often open this formula or apply the square on alpha plus beta, so we get alpha square plus beta square plus 2 alpha beta minus 2 alpha beta plus 2 alpha beta minus 2 alpha beta cancel, so we get again alpha square plus beta square. So we write alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha beta. So here we can put the values of sum of roots and products of roots. Alpha plus beta is equal to minus b divided by a, and alpha beta is equal to c divided by a. Now we will do simple apply to a whole. We will simply apply the square, which we get b square divided by a square minus 2c divided by a. Now if we take the LCM of a square and a, we can write a square in the numerator, and the denominator and denominator we can write b square and minus 2ac. This is the required values of alpha square plus beta square. Now we have alpha cube plus beta cube. So now we can write alpha cube plus beta cube is equal to alpha plus beta, sum of the products, power cube, power 3 minus 3 alpha beta into alpha plus beta. Now here we simply put the values of alpha plus beta in alpha into beta. If we put the values of alpha plus beta, which is b minus b divided by a minus 3 into c divided by a into minus b divided by a. Now we apply cube So we get minus b cube divided by a cube minus 3bc minus into minus we get plus, so we can write 3bc divided by a square. Now we write a 3bc first divided by a square minus b cube divided by a cube. Now if we take the LCM of the denominator, so we can write a cube, a square and a cube is the LCM is a cube, and in the nominator we can write 3abc minus b cube, which is the required values of alpha cube plus beta cube.